Chris Adova, and today we're going to be talking more about operator overloading and what derived what classes. Okay, we're talking about operator overloading and what derived classes. So first of all, let's take a look at our objective. We are supposed to learn the concept of operator overloading and learn about what derived classes, learn how to implement inheritance and what polymorphism. Okay, so let's dive deep first into operator overloading. Operator overloading defines how what operators behave for user what defined data types like classes, objects, and structures. Like classes, sorry, into brackets, objects, and what structures, which are also known as what variables. Okay, so operator overloading in what C++ program can what add special features to the functionality and what behavior of already existing operators, such as mathematical and what other operators. Okay, let's move on. Let's take a look at this. The plus operator, when used with what values of type int, returns what their sum. Okay, we are talking about addition. Okay, talking about the plus operator, and when used with what integers. Okay, which are whole numbers as a whole. Okay, something like 5 plus the operate with the operator plus 5 was plus what 5 is going to give you what 10, because you are using the word function int, also known as what integers. Okay, returns their sum. Okay, just like the example I did, 5 plus 5 equals 10. 10 is the whole total sum of that. However, when used with object of what a user defined data type, it is an error. Okay, when you use an operator with what a user defined data type, you are going to get an error. It's basically what not possible with that. Okay, so let's move on. Operator we visited. Arithmetic operation, that's when you have the plus, asterisk, slash, and what percentage. Logical operations, you have what and what the bars, as you can see there. Relational operations, pointers, pointer operators, memory management operator, new delete, as you can see. Let's take a look at this. Let's take a look at what operator overloading types. Okay, operator overloading types. What are the types of what operator overloadings that we have out there? So types of operator overloading. You have function overloading and what operator overloading itself. Okay, function overloading, overloading a function and overloading an operator. Sorry. Okay. So operator overloading. Let's take a look at the syntax. Return operator symbol parameters. Okay. So this, as you can see, just some few basic full stops over there. Now let's take a look at a breakdown of it. The return type. The return type of the function. Okay. Operator is a what? Special keyword. Operator is a special keyword. Okay. Let's take a look at the symbol. The operator you want to overload. Plus, less than, minus, plus. Okay. Then the parameters. The parameters defined in the what function itself. What the parameters that are going to be defined in the function, okay, are also what under what operator overloading breakdown. So operator overloading. Let's take a look at the syntax that we have down here. You have int operator and what plus plus h. So I'm going to implement this same syntax right into what? Right into our what C++ compiler. Okay, we have the int operator. Okay, we have the int operator, then we have our what double addition sign with our what parenthesis, and in the parenthesis we have int what age, then we have our what curly braces. In the curly braces we have, that's when we have our what return plus what age. Okay, so this is a what simple example of what an operator overload. overloading. Okay, simple sample of what or syntax of what operator overloading right here as you can see. This right here, sample of what operator overloading. Okay. So now let's move forward on. So the forbidden overloading rules. Okay, we have the what ternary or conditional what operator. Okay, which is the question mark and what a semicolon. The scope resolution operator, which is what the double columns. Dot operator or what member selector. Okay, we talked about members and what attributes. Okay, so the pointer towards member operator and the what object type operator, type it, object size operator, size of, and what object alignment operator. Okay, so the forbidden overloading rules. I still continuing on that. You have what only existing operators can be what overloaded. Okay, only existing operators can be what loaded. Okay, so we keep that in mind. Only existed what operators can be overloaded. New operators cannot be created. Into bracket only built-in operators that can be overloaded. So new operators what cannot be created. Only built-in what operators that can be overloaded. So when let us say an operator is trying to be built, it can be what created, okay, but only be built in what operators that can be overloaded. Okay, so there are some operators there that we know about that can be what overloaded. We are not talking about the operators, we are simply talking about what the symbols that are using what the arithmetic calculations and other stuff. So existing operators cannot be renamed. Okay, existing operators cannot be what renamed. At least one of the what operands in overloaded operators must be what user defined. Okay, forbidding overloading rules. If it's not possible to change the number of what operands of an operator support, default precedence what association of operators are what maintained. Okay. So let's look at some advantages of what operator overloading. Some few advantages are what operator what overloading. Simplified syntax allows simplified syntax, sorry. This allows the use of what notation closer to the target domain. Okay, it allows the use of what notation closer to what the target what domain. Consistency, similar support to what to build types in what user defined what types in to build in types for user defined types. Okay, and then for what easier understanding, use of familiar operators with user defined types are being what just for you easy understandings. Let's look at some disadvantage of what operator overloading. Potential misuse. Okay, looking at potential misuse. The abuse of what or misuse can lead to what unexpected what behaviors. Okay, the abuse or misuse can lead to what unexpected behaviors. So when you're abusing what an overloading, an operator overloading, the abuse or misuse can lead to what unexpected behaviors. Means anything can literally happen whilst you are overusing it or abusing it. Okay, complexity, overuse or misuse introduces complexity. So when you overuse this what operator overloading techniques, it simply what creates or what forces the program you're trying to create to be complex in its own way. Okay, given a different kind of what buffs, I'm going to say buffs. Okay, given a different kind of buffs that it wasn't supposed to do, complexity, trying to be complex in what always and all means. Okay, limited overloading. Not all operators are what overloaded. Okay, not all operators are what overloaded. So now let's take a look at what a derived class. Okay, a derived class. When we talk about derived class, what comes in mind? A derived class is what's created from an existing class. Okay, talk about the class where we have what you have the class function itself and the class name. Okay, so a derived class is a what class created from what an existing class. It's created from what an existing class which has already been created. The derived class inherits all members and what member functions of a base class. It inherits all the members and what member functions of a what base class. So once it's being derived from there, it inherits everything from what a class function that I just created. Okay. Also, the derived class can be what can have more functionality with respect to the base class and can easily access the base class. Okay. Can have more functionality with respect to the base class and can easily access the base class. Okay. A derived class is also called a child class or what subclass. I mentioned about that in what our project 9. Okay, the lecture 9 I mentioned about a child class but didn't go deep into it. But now I'm going to talk about that. So derived class definition begins with what? The keyword class, followed by what? The derived class name. Okay, with the class itself, we say it followed the keyword class and just what? The class name itself. But now we are saying what? After writing or typing in class, you're supposed to add derived class name so that you can derive it from what? The mother class. I'll call it the mother class here because yeah, it's basically coming out from the what? The main class itself. Then column followed by what? Access specifier and base class name. Okay, as you can see it here, this is how it's going to really look like. Class derived class. Okay, let me implement this in the C++. Okay. So you are saying that what you are just supposed to write something like class and add derived derived class what name. Okay, then we bring in our what our colon, then what access underscore what specifier what base what class name. Okay, so that's when we have what right here. That's when we have the access specifier, the attributes, and we also input what the methods. Now let's look at this class definition. Okay, yeah, like what's class definition itself begins with the keyword class and follows by what the name itself. Yeah, so class and name, as I did earlier, I did about the dog. Yeah, dog, and we have what access specifier, attributes, and what the method. Okay, so we are going to be implementing this code right here into what our C++ what compiler. Just going to be making a syntax of what the code itself. Okay, so the first thing, I move this here a little. Okay. So the first thing I'm going to do is derive class what definition. That's when you have to type in the what the class, the what derive what record, right? Just remind you, I'm just making a syntax of it, not what public what record. Okay, we open our what curly braces, open our curly braces, then we input in our what our access specifier. Okay, this is our access specifier, access specifier, right? Then we input in our what child grade is our what attributes. Okay, right there's our attributes. Then we input our child what get what grade, trying to get a grade. Okay, so fetch it out for us. Then input this, then terminate on that. Okay, this right here is going to be what our one and only what method. Okay, so with that, there's a simple syntax about that. Then what we're going to move on talking about using access modifiers, right? So access modifiers such as what's public, private, and what's protected can be used in inheritance using what derived classes. Syntax Sorry. Syntax. Let's talk about syntax. Class group B record, my public record. Okay. This is it right here. Okay, just a mistake. Public, my record. Okay. So derived class using access modifiers public if a derived class is, a, is declared in public access. And the members of that base are inherited by what? The derived class, just as they are. Since we are saying that what they are going to be deriving, they are going to be derived from what? The mother what section of code. They are just basically going to be doing with the same functionality, the same complexity, the same everything about them is just going to be the same. Okay, there's nothing changes about that. But when you overload what different operators or functions, it might cause what different complexity. Okay. So let's look at private. If a derived class is declared in private access, then all members of the base class become private members in the derived class. Because all the members in the what base class become private members in what the derived class. Okay, just the same. You inherit it from what the base class. Come back to what the child class is just going to be the same, or the derived class, sorry, it's just going to be the same. Nothing is going to change about that. Protected. The members put the public members of what the base class become what protected members in the derived class. Okay, since they are protected there, the child class will also be what be protected as well. The private members of the base class are always private in what the derived class, like mother, like son. Let's drive class using modifiers. We have the word syntax. Okay, that's when you use the class D group record, what's public, my record. Okay, these are just some simple syntaxes. That's when you use public, private, protected. These are going to use them in what? A code, or this is just a simple syntax generated under them. Okay, and the class group D record, what we have our what column, it's our what public what attributes right there with what my record curly braces and put whatever I want to put in there, whatever I want to get. If it's int age, if it's string, if it's what char, any kind of function you want to put in those parentheses, you put it in there. It's going to be public for what everyone to view. Private is going to be private. Protected is still going to be protected. Okay, so let's go to inheritance. Inheritance allows one class to reuse attributes and methods from another class. Okay, it helps you write cleaner, more efficient code by avoiding what duplication. Okay, with the inheritance, it helps you reuse attributes and methods from another class. But what gives you a cleaner code and a more efficient code and avoid what duplication. Means it doesn't duplicate the same exact code, but it reuses the attributes and methods from that class. Okay, so let's talk about the types. We have derived class, child, which is the child, and base class, which is the parents. Okay. The inheritance. Inheritance allows us to what create a new class from an existing class. Child class from what a mother child. Now I'll just call it a parent, or yeah, parent child. Sorry about that. The derived class inherits what the features from what the base class and can have additional features of what of its own. It inherits the features from what the parent class and can also what have features of what of its own. Like giving birth, but your child doesn't look exactly like you, is going to have its own features as well. Wow. Sorry for that. So inheritance. Let's look at the flow process of what inheritance. Now let's take a look at this. The animal. Okay, it eats, sleeps. Okay, derive class from what? That same animal. That's an animal right there. Trying to derive what eats and sleeps. It's a dog. You derive it from what the parents. Okay, eats and sleep. And you derive what? Dog from that, because a dog eats and sleep as well. Okay. So inheritance could be have the class animal, then what? Open parentheses. Eat parentheses. That's the method right there. Okay, eat. That's the method right there. You have what? Sleep is also what the method we have. You then you have class dog, class, then the what the name of the class. We have public animal, then we have what the new method as well. This is going to be what our what derived or inheritance what our inherited what class. Okay, this is our inherited what class, and this is our what our parents class right here. Okay, this is our parents class, and this is going to be what our inherited what class. There are five types of what inheritances. We have what single inheritance, multi-level inheritance, multiple inheritance, hierar- hierarchical inheritance, and hybrid inheritance. Okay, single inheritance from what? One single parent class, multi-level in it's simply what? Should I say the code what? Let's just say the class that you're using is a little bit what more progressive or what more intense, or should I say more, which word am I going to use which is going to make this vivid? More enhanced. Okay. Then we have what? Multiple inheritance, which means what? Inheriting from what? Different multiple classes. Okay. Inheriting from different multiple classes or different multiple parents at a go. You have the hybrid, which inheritance it's inherited it gains inheritance from what? A class itself, and then what? Something different or other than a class. Okay, that's a hybrid right there. So as you can see, inheritance, multiple land view, amphibious water vehicle. Okay, multi-level class for will, as I said, then hierarchical. Okay, just like a hierarchy. Okay, hierarchy. Then we have hybrid. Okay, as I said earlier, it's inheritance. It's inheritance. It inherits from what? One class and what gains from what another class as well. Okay, not like a bloodline or something. So let's look at some few rules. You have some static members are class dependent and are not inheritable. Again, static members depend on a class and cannot be what inherited. You have friend classes. Friend classes can what be inherited. Okay, and constructors and what distractors are not inheritable. A constructors and distracted. Constructors they create what simple classes or what simple attributes, and distractors are simply what that's what just destroy some simple line of code in what's your class. Okay. Then let's talk about polymorphism. This means what? Many forms, and it occurs when what? We have many classes that are related to each other by what? Inheritance. Many forms that occurs when we have many classes which are related to each other by what? Inheritance. Just like having a brother and sister. You inherit something from what? Your dad, one-sided what? Parent. Okay, you're inheriting something from one side of the parent. It uses methods inherited from what? Another class to perform different tasks, and what redefines a base class member function towards the derived class. Okay, so this is it right here. We have class, what we have the name and record, have the public function right there, which is what going to be what our attributes. Then this right here, our attribute, then our method down here. Then we are going to see our age is this my age. As you can see, the distractor signal right there. Okay, so another one right here too. So this brings us what to the end of our what week 10 what lecture video. And mind you, my name is Chris Above. Hope to see you very soon as well. Thank you and bye for now.